Hey guys, and welcome back to another GCSE Maths Grade 9 exam question. And today we have this question where we're given a rectangle and we're given a right angled triangle, and we're told that all the measurements are in centimetres and that the area of the rectangle is greater than the area of the triangle, and we have to find the set of possible values. So this is important, this bit here where it says the set of possible values and the part where it tells us that it's greater. This tells you that you're dealing with quadratic inequalities here. So this is a good start if you can spot what we're working with. So let's start with the basics. The area of a rectangle, so it's going to be 3x minus 2 times x minus 1. And we know that this is greater than the area of the triangle. So 3x minus 2 times x minus 1 is greater than the area of the triangle. So 2x times x divided by 2. So that's going to be x squared, because that would be 2x squared divided by 2, which gives us x squared. So we need to expand this left-hand side and then solve the inequality here. So 3x times x is 3x squared. Now I'd be doing 3x times minus 1, so that's minus 3x, and I'm going to do minus 2 times x, that's minus 2x, so minus 3x minus 2x minus 5x. So I've skipped the simplifying step here in the expansion of the bracket, but hopefully that's okay, and that gives me minus 2 times minus 1 to give me plus 2. And this is greater than x squared still. So now, like just solving an equation, we need to make this equal to 0, or in this case it's going to be greater than 0. So if we subtract x squared off, that's going to give me 2x squared minus 5x plus 2 is greater than 0 still. And now, let's look to see if this can factorise, which is very often the case with these quadratic inequalities. So because 2 is prime, but it has to be a 2x at the start of one of them. And I'll close the bracket so we can look at what we're working with. So this one has to be an x clearly, greater than 0. So we need a plus 2, so they're either going to both be positive or both negative. So I'll keep it as negatives for now. And we need a minus 5x. So this is clearly going to look like it's going to be 2 negatives. So if I put minus 2 here, so 2 times minus 2 gives me minus 4. Then I put a minus 1 here. Yeah, that's going to give me the minus 5. Perfect. We found the factorisation. This looks good so far. Now, at this stage, what I always say to students is find the critical values. So that's going to be when this is equal to 0. If you solve this like a normal equation, so 2x minus 1 is equal to 0. So that would mean 2x equal to 1, which would mean x is equal to a half. Like that. And similarly, this would be 2. Now, I always say as well, draw a sketch so you can see what you're working with. So, for example, for this, now this is just a sketch, it's not going to be perfect. As you see by the fact that the graph is tilting upwards, that's clearly not how it should look. But it's going to look something like this, right? It's going to cut through at, 2. It's going to cut through at half, and come back up at 2. So if that's your half here, so that's half, and this is 2 here, you've got to figure out now where this graph is above the x-axis. So this is clearly here, past here, and it would also normally be down here, right? I'd normally agree there. But think about what we're working with here. We're working with lengths. Now, the rectangle has a length, or a side length, of x minus 1. So that would be less than, so what we're saying is that any value is less than a half. So for example, I don't know, 0.1. So if you did 0.1 minus 1, well, we're going to get a negative value. This isn't going to work. So we can't include these values here. So the only set of possible values that we can have, therefore, is that x must be greater than 2. We can take any value bigger than 2, but we can't include the values here on this side. So that's just the only answer we can have. X is bigger than 2.